Welcome back to Science Meets Adventure. Imagine this. You are hiking high above the tree line. The trail is narrow. The air feels heavy. A few minutes ago, the sky was bright. Now, towering clouds are rising like dark mountains above the real ones. The wind changes. The temperature drops. Then, the whole horizon flashes white. A second later, thunder slams across the valley. In moments like that, lightning does not feel like just weather. It feels alive. But inside that storm cloud, something even more incredible is happening. Tiny collisions, invisible charges, a massive electrical imbalance building silently overhead until the sky can't hold it anymore. So how does lightning actually form? Why do some storms explode with electricity? And what should every hiker, traveler, and explorer know before getting caught under the wrong cloud? Let's step inside the storm. Lightning is basically a giant electrical discharge. In simple terms, it is nature releasing a huge buildup of electrical energy all at once. Think of the little shock you get after dragging your feet across a carpet and touching metal. Now scale that up to the size of a mountain range, a storm cloud, and millions of volts. That is lightning. But it doesn't begin with the flash. It begins with heat. Most powerful lightning comes from towering thunderstorm clouds, called cumulonimbus clouds. These are the giants of the atmosphere. They don't just spread across the sky. They grow upward, sometimes reaching more than 10 or 15 kilometers into the air. They form when warm, moist air near the ground starts rising fast. As it climbs, it cools. Water vapor condenses into tiny droplets. The cloud grows. More warm air rises. The cloud pushes higher. And soon, what looked like an ordinary afternoon sky becomes a vertical engine of wind, water, and ice. Inside that cloud, chaos takes over. Powerful updrafts throw droplets upward. Ice crystals spin through freezing air. Heavier clumps of soft ice, called graupel, tumble downward. Everything is moving, colliding, breaking apart, rebuilding. It is less like a quiet cloud and more like a violent machine running in the sky. And that chaos creates charge. When ice crystals and graupel crash into each other, they exchange electrons. Over time, the storm begins to separate itself electrically. Lighter ice crystals usually gain a positive charge and get carried to the top of the cloud by strong rising air. Heavier graupel tends to become negatively charged and gathers lower down. Now the cloud has a problem. The top is mostly positive, the bottom is mostly negative, and the difference between them keeps growing. You can think of the storm cloud like a giant battery charging itself over your head. The bigger the charge separation gets, the stronger the electric field becomes. Not just inside the cloud, but between the cloud and the ground below. And the ground responds too. As negative charge builds at the bottom of the cloud, positive charge begins gathering on the surface beneath it, especially on tall, sharp, exposed objects. Mountain ridges, lone trees, tent poles, observation towers, even people. That is why lightning matters so much to adventurers. When you are out in the open, the landscape itself becomes part of the storm's electrical system. Then comes the breaking point. Normally, air acts like an insulator. It resists the flow of electricity. But if the electric field becomes strong enough, the air starts to fail. A faint, branching channel of charge begins reaching downward from the cloud. This is called the step leader, and this part is wild. The step leader doesn't shoot down in one bright, dramatic bolt the way movies make it look. It moves in jagged, nearly invisible steps, probing through the air, searching for a path, branching, splitting, feeling its way toward the ground. As it gets closer, objects below begin sending up their own faint streams of positive charge. And the moment one of those upward streamers connects with the descending leader, the circuit is complete. That is when the sky explodes. A massive surge of current races along that path in what's called the return stroke. This is the brilliant flash we actually see. In a fraction of a second, the air around the channel is heated to temperatures hotter than the surface of the sun. The air expands violently. That shock wave rolls outward through the atmosphere, and we hear it as thunder. So the lightning flash is really the final visible burst of a process that was building long before you ever saw the sky light up. And lightning does not always strike from cloud to ground. Sometimes it jumps within the same cloud, sometimes between different clouds, sometimes out into clear air. But for anyone who loves hiking, climbing, paddling, or traveling through exposed landscapes, cloud-to-ground lightning is the danger that matters most, and some places are especially prone to it. Tropical regions produce frequent thunderstorms because warm, humid air rises fast. Mountain ranges are natural storm factories because terrain forces air upward. Open plains, deserts during monsoon season, and coastal areas can all become lightning hotspots under the right conditions. That means if you love adventure, you are often moving through exactly the places where lightning has the best chance to form. So here's the rule that matters most. If you can hear thunder, you are already within striking distance. Not close to the storm, within striking distance. Lightning can hit far from the rain core, sometimes when the sky above you still looks partly open. That is what makes it so dangerous for travelers. People often wait too long because the storm does not feel close enough yet. If you are outside and thunder starts rolling, get to proper shelter fast. A real building is best. A fully enclosed vehicle with a metal roof is also a good option. Avoid isolated trees, high ridges, open water, metal railings, and exposed viewpoints. If you are hiking in the mountains, turning back early is not weakness. It is smart field judgment. The best adventurers are not the ones who challenge every storm. They are the ones who know how to read one. That is what makes lightning so fascinating. It is beautiful, violent, and deeply logical. A storm cloud rises. Ice and water collide. Charges separate. The electric field intensifies. The air breaks down. The sky releases its energy in one blinding flash. What feels like sudden chaos is actually physics unfolding at incredible speed. And once you understand that, a thunderstorm becomes more than just dramatic scenery. It becomes a story you can read, a warning you can recognize, a force you can respect before it gets too close. That is where science meets adventure. If you enjoyed this video, like, share, and subscribe to Science Meets Adventure for more journeys into the wild side of science. And in the comments, tell us, what is the most unforgettable storm you have ever witnessed while traveling or exploring?